Hello dear students, welcome to a new math session. In this session we're going to learn about classifying triangles according to their angles. We studied before that the type of the triangle according to its angles can be identified due to the type of the greatest angle in measure. Let's see this remark. The remark says, in any triangle, either it's right, acute, or obtuse, we find that the length of any side of the triangle is greater than the difference between the lengths of the other two sides and less than the sum of their lengths. If ABC is a triangle, then BC minus AC is less than AB, and AB is less than BC plus AC, and so on. Determining the type of the triangle according to its angles in case of knowing the length of its three sides. To determine the type of the triangle according to its angles in case of knowing the length of its three sides, we should compare between the square of the length of the longest side of the triangle and the sum of the squares of the other two sides. Then, this comparison will determine the type of the triangle as follows. If the biggest side squared is equal to the other two sides squared plus each other, then it is a right angle. If the longest side squared is greater than the sum of the squares of the other two sides, then this is an obtuse triangle. If the square of the longest side is less than the sum of the squares of the other two sides, then it is an acute triangle. Let's go to the exercise part and solve exercise 1 that says choose the correct answer. Question 1. A triangle whose side lengths are 5, 12, and 13, its area is what? 5, 12, 13, we know that it is a right triangle. How do we know this? We will see that here 13 squared is equal to 5 squared plus 12 squared. So this is a right triangle. To find the area is half times base times the height, which are the 5 and the 12, because 13 is the hypotenuse. So the answer here is 30 centimeters squared. Question 2. ABC is an obtuse angle triangle at A. If AB is 4 and BC is 7, then AC can be equal to how many centimeters? As long as it is an obtuse triangle, then BC squared, which is the 7 squared, must be greater than AB squared, which is the 4 squared, plus the coming one squared. So 49 is greater than 16 plus what number is squared? So in this case, x will be equal to 5. Question 3. ABC is an acute angle triangle in which AB is 6 centimeters, BC is 8 centimeters, then the length of AC can be equal to what? For sure it cannot be 2, because 2 plus 6 is 8, so 2 is not a right answer because the sum of two sides must be greater than the third side. So in this case, it will be 6. Why would it be 6? Because 10 makes it a right triangle and 14 makes it an obtuse triangle. Question 4. ABC is a triangle in which BC squared equals AB squared plus AC squared, where angle B is 40 degrees. Then what is the measure of angle C? As you can see here that we have a triangle and what's given is the Pythagoras theorem, right? Excellent. And as long as this is plus, so BC is the hypotenuse. So here this is A and here is the B, here is the C. So if B is 40, what is the measure of angle C? The measure of angle C is 90 minus 40, which is 50 degrees. Let's now go to exercise number 2. In the opposite figure, the question wants me to find first the length of the projection of AD on BD straight line, and second, the question wants me to determine the type of triangle BCD according to its angles. For question 1, the projection of AD on straight line BD, it is segment BD. So now this is the projection. But the question here does not want you to find the projection, but the question here wants you to find the length of the projection. As you can see that in the right triangle ABC, BD equals square root of the hypotenuse, which is 17 squared, that is AD, minus the other leg, which is the AB, which is 8 squared. So if you do your calculations, BD equals 15 centimeters. For question 2, what is the type of triangle BCD? If we got that BD is 15 centimeters, so we're going to do BD squared as one side, and the other one CD squared plus the BC squared. So 15 squared, and here we have it 12 squared plus 9 squared. 15 squared is 225, where here is 144 plus 81, which is 225 as well. So as long as they're equal, so triangle BCD is a right triangle. So triangle BCD is a right triangle at angle C. Exercise number 3. For this opposite figure, the question wants us to prove that angle ABC is an obtuse angle. As long as ABCD is a parallelogram, so for sure AD is 15 centimeters long and AB is 8 centimeters long. So let's write this down. Since ABCD is a parallelogram as given, therefore AB is equal to CD is equal to 8 centimeters. So if we want to check triangle ABC, the longest side is 19. So we're going to make AC squared, and on the other side BC squared plus AB squared. So AC squared is 19 squared, and here it's BC squared, which is 15 squared, plus AB squared, which is 8 squared. 19 squared is 361, where 15 squared plus 8 squared is 289. So we can see that the 361 is greater than the 289. So since AC squared is greater than BC squared plus AB squared, therefore triangle ABC is an obtuse triangle at angle B. So therefore angle ABC is obtuse angle. Let's now move on to the evaluation question. Dear students, as I always remind you, pause the video, answer the question yourself, play the video after that to verify your answer. In this question, the question wants us to prove that ACD is an obtuse triangle. Since triangle ABC is right triangle at angle B. Therefore, AC as a hypotenuse equals 24 squared plus 32 squared. So AC is equal to 40 centimeters. Let's now move to triangle ACD. Which one is the longest side? It's 45. So we're going to check 45 squared, and we're going to check the other two, 40 squared plus 9 squared. 45 squared is 2025, where 40 squared plus 9 squared is 1681. As long as the 2025 is greater than the 1681, so this tells us that AD squared is greater than AC squared plus CD squared. So therefore, triangle ACD is an obtuse triangle at angle C. At this point, dear students, we came to the end of our session. Thank you very much and wishing you best of luck.